1.5. So the quadratic equation has this form. Okay, so listen carefully. It has the form ax squared plus bx plus c equals 0. So that's the form of a quadratic equation. And you solved quadratic equations last year. That was one of the last things you did in Math 99 was solve quadratic equations. In fact, there were 1 or 2 in your final last semester. So that is a quadratic equation. Now what makes it quadratic is what term makes this a quadratic equation? The x what? X squared. The x squared term makes it quadratic. So that x squared wasn't there, then this would be what kind of equation? Linear. So it would be a linear equation. But the fact that x squared is there makes it quadratic. Now, a, b, and c can be any real number. A, b, and c are any real number. But a cannot equal 0. B can be 0. You're going to see that in a little while. C can be 0, but a can never be 0. So when we look at all these quadratic equations, you'll notice that a is never 0. Why do you think that a is never 0? Because if it was, what would happen? If a was 0, what would happen? No, that would still be an equation. It's just that if a is 0, this is 0, right? What kind of equation are you left with? Linear. So if a is 0, you no longer have a quadratic. You have what instead? A linear equation. All right, so that's why a can never be 0. So if you want this to be quadratic, a has to be a number other than 0. Okay? Now, let's kind of review something. This is the simplest kind of quadratic equation that I'm about to give you. But the way you're going to solve it you've done this before. You may have forgotten though. But the way to solve it is a particular way, the easiest way to do this particular kind. Let's suppose you were asked to solve this. Solve x squared equal 9. In fact, you can even guess at the answer. What's the solution? 3. 3 is a solution because 3 times 3 is what? 9. Is that the only one? No. What else? Not 9 squared is 81.
No, square root of 9.
No, someone said a while ago. Negative 3. Negative 3. Negative 3, because what's negative 3 times a negative 3? Positive 9. Now you see how for the most part you got one of them. All of you got one of them. You said 3. But you forgot about which one? Negative 3. Because a negative 3 times a negative 3 is also a positive 9. Now the way you solved this before was this way. Now listen carefully. You remember, just like the equation we did earlier, we always try to get x by itself, right? Right now I don't have x by itself. I have what? X squared. Okay, so listen what you did. What is the opposite of squaring? Square root. The opposite of squaring is square root. But what you do to one side, you do to the other. So you said square root, square root. But when you took the even root, remember, if there's no this x right here, this x that I have here, that's the index. So that's your index. This number right here, that's a number sign. That's your radicand. So if there's no index, what is it understood to be? Not 1. 2. Square root, right? Square root. 2. In fact, your index can never be 1. It can be 3, 4, 2, 5, and so on, but it can never be 1. What's the smallest index you can have? 2. So if this was cube root, then I would have to write the 3. If this was fourth root, then I would have to write the 4. But since it's a square root, do you write the 2? No, it's understood to be a 2. All right, so you take the square root of both sides, but remember, how many solutions am I supposed to have? 2. A positive and a what? Negative. So you may remember now, we did a plus and a minus. Plus or minus. So that's called the square root property. The square root property. So one way to solve a quadratic equation is to use the square root property. Square root property. But when using the square root property, it's got to look like this. It's got to be some expression squared equal a number. Some expression squared equal a number. So on the left side, you're supposed to have something squared. On the right side, you have a what? Number. If that's the case, then I can use the square root property. So if you have some expression, and it's being squared, and that's equal to a number, then I can take the square root of both sides, just like this. The square and the square root undo each other. They're inverses. You're going to talk about inverses later on. You're left with what over here? U. So U equals, and what must I write? Plus or minus the square root of D. So when I do this one, that's square root property. So when I do this one, I take the square root of both sides to get rid of the square. So the square and the square root undo each other. You're left with what? X equal plus or minus, and what's the square root of 9? 3. So those are your solutions. Okay? Those are your solutions. So number 2. 4x squared plus 9. Let me make it simpler for right now. 4x squared, well, that's fine. Plus 9 equal, let's do minus 9. Minus 9 equals 0. Just do minus 9 for right now. Yeah. First of all, is this quadratic equation? Yes, because x squared, I see an x squared, right? Okay, so it's quadratic. What term is missing? The x term is missing. Remember, the form looks like this: ax squared plus bx plus c. Do y'all see there's no x term? There's a x squared term. There's the constant term, the c, constant. There's a constant term, but what term's missing? The x term is missing. Whenever the x term is missing, the quickest way to do that is to use the square root property. So let's use the square root property. To get the square root property by itself, though, what's being squared has to be by itself. Very good. So I have to do what first? Add 9 to both sides first, because I got to get that squared. I have to get it through whatever's being squared. I've got to get it by itself. That's what this says. So I'm going to add 9 to both sides. Combine like terms. I get 4x squared equal 9. That's where I'm at. Okay? But I don't want to take the square root of both sides just yet, because I got to get that what's being squared by itself. So that means I got to get rid of what next? Divide both sides by 4, and we're almost done. 4 divided by 4 is 1. I get x squared equal 9/4. And now I have something that looks like this. Something squared equal a number, right? So to get x by itself, I got to get rid of the square. What's the opposite? Square root. Now notice when you do this, you say square root, but what else must I write? Plus or minus. You must say plus or minus. Because they're supposed to be how many solutions? 2. The square and the square root undo each other, and you get x equals plus or minus what?
3/2.
3/2. The square root of 9 is 3. The square root of 4 is 2. So there are your solutions. So there are how many solutions? 2. 3/2 and -3/2. Now in my math lab, On my math lab, they're going to tell you to separate the solutions using commas. Separate the solution using commas. So on my math lab, you're going to say this. You're going to say 3/2, comma, -3/2. And it doesn't matter whether you put the negative first or not. But that's the way you're going to write on my math lab. You could even on the worksheet do the same thing. You can say plus or minus 3/2 if you want to on the worksheet. Or you can say 3/2, comma, -3/2. Does not matter. Okay? Does not matter. All right, let's look at another one. Suppose you had this. Okay, number 3. Suppose you had 9x squared plus 4 equals 0. 9x squared plus 4 equals 0. Can I use the square root property here? Yeah, I gotta do some stuff, but I can use the square root property. I know I can use the square root property because what term is missing? The x term. So I can use the square root property. I gotta do some things though. What's the first thing you're gonna do? Subtract 4 from both sides. And I get 9x squared equals a -4. And then do what? Divide by 9. And notice here's what I have so far. I have x squared equal a -4/9. That's what I have. But remember, you got to get x by itself. Right now I'm squaring. What's the opposite? Square root. So you take the square root of both sides. But when you take the square root of both sides, you need what on this side? Plus or minus. So the square and the square root undo each other just like this. So what's left? X. All right, now be careful. You are taking the square root of a negative number though, right? Okay. So what am I going to end up with? I. You're taking the square root of a negative number, aren't you? Got to remember that. So if that negative wasn't there, what's the square root of 4/9? No, if the negative wasn't there. 2/3. But since there is a negative in the square root, it's 2/3 what? I. Okay. 2/3 I.
Do we have to write 2/3 I? Can we write 2I? 2 I.
That's fine. Yeah. Oh, but what am I missing? I'm missing the plus or minus. Okay, plus or minus. On the math lab, you have to say. Well, the i's in the numerator. You never. Oh, and I'm glad you brought that up. Some students, when they write it, I can't tell where the I is. So this is fine. But some students will do something like this. That I looks like it's located where? In the denominator. So I'm confused as to where you put the I. So don't write it like this. Okay, make sure you where you put it. It looks like it's located in the numerator. So like that, or you can just say 2I over 3. Okay, not 2 over 3I, right? Yes.
If I just write it completely next to it,
If you write what?
the I completely next to it, does that still count as an answer, or do I have?
What do you mean by completely next to it?
Like next to the dash?
Yeah, next to the dash.
Yeah.
Okay, when you say the dash, you mean this?
Yes, sir.
So you're talking about this?
A little lower, like in between.
Oh, no. If you do, no. He's saying this. Is that what you're saying? Okay, why don't you write it out and then show it to me? Write it out and show it to me, because I'm a little confused as to what you say right below it. Okay. So to be on the safe side, you either put it in the numerator, like I did here, or you put it on the side to where it's on the same level as a division symbol, right? Okay.
That's what I was saying.
It's going to be on the same level. So in other words, if this was lined paper, this is your lined paper, right? Okay. All right.
It matters, Mr. B, because it's not half a point, you know.
Well, in this case, it'll be more than half a point. All right, number 4. Suppose you had this. 3x minus 2 squared equal negative 16. 3x minus 2 squared equal negative 16. Write this down. All right. So think, ask yourself, can I use the square root property here to get x by itself?
No.
Why not? Yes, you can. Remember, the whole idea was this. If I can get something squared equal a number,
Oh,
then I can use the square root property. So do I have something squared equal a number? Yes, I do. Okay? So I'm going to go ahead and rewrite it over. Now I'm going to say this. You're going to learn also there's always someone that does this. They FOIL this out. 3x minus 2 is 3x minus 2. They get a trinomial. It's going to end up being a trinomial. And you get a quadratic equation that looks like this. At that point, you could factor and get your solutions. And we're going to do one in a little while. But the point is this. If I can use the square root property right away, I'm saving some time. Now, you can't always use the square root property, but if you can, you use it. So what we're doing right now is the square root property. So if I take the square root of both sides, just like this, plus or minus, don't forget plus or minus, the square and the square root undo each other, and what are you left with? 3x minus 2 equal plus or minus,
4x.
4i, good, 4i. Okay, any question at that point? All right, now, the way you want to do the steps, the steps that we do next is the way you want to do this. So you see you have an I, right? You have an I. So it is okay then to get x by itself by just adding 2 to both sides first. Just like this. Now be careful. We combine like terms. Are these like terms right here that I'm pointing to? No. This has an I. Does this have an I? No. So all you can do is write this as 2 plus or minus 4i. That's all you can do. Those are not like terms. Don't say that's 6i. Because in order for you to combine these, this has to be an I with it. Okay?
I
So,
have a question.
yes.
Why is the 2 on the other side of the plus or minus? It wouldn't be 4i plus 2?
Well, okay, so you do see that's plus or minus, right? 4i. So here's a confusion. So she's asking, why is the 2 on the left side, and why is the 2 not on the right side, right? That's her question. So she's asking, why is it this and not this? Because we tend to put the plus or minus after the constant too. It looks better like this. When we do the quadratic formula, you're going to have that plus or minus in the quadratic formula like this. Now I'm hoping that you realize that you can't combine these right here, because that's not an I. So we tend to put the plus or minus term at the end. This looks a lot better. This right here looks a lot better than this.
Is it wrong?
It's not wrong, but that's not the way you want to write this.
It's not mathematically correct.
No, well, it's not the way we mathematically write it. I mean, mathematically it's correct. There's nothing wrong with it, but that's not the way we write it. If you tend to write this, at some point you might get confused with some other stuff. What's the next step?
Divide by 3.
Divide by 3 and you're done. You found your solutions. So x equals 2 plus or minus 4i divided by 3. Now, I've got to explain this, though. That's your solution. How many solutions are there? 2. There are 2 of them. On My Math Lab, they're going to ask you to separate the solutions using commas. So here's what that means. On the worksheet, you can write it like this. On the worksheet. On My Math Lab, you have to do this. You have to say 2 plus 4i over 3, and what's the other? 2 minus 4i over 3. Those are your two solutions. So that's how you write them. That's your solution. These are your two solutions. We just wrote in this compact form because it was plus or minus 4i. Another way you can write this, on my math lab, they will also accept this on my math lab. You remember when we did the standard form a plus bi? So if you want, you can say 2/3 plus what? 4 over 3, and then 2/3 minus 4 over 3. That's fine as well. Okay? So there are multiple ways of writing the answer, but don't write it as plus or minus 4i plus 2 over 3. I don't want you to write it like this. I want you to write it where that plus or minus in the middle. Okay? All right, now, let's look at this one. Number 5. All right, number 5. We have 2x plus 3 squared equal 12. 2x plus 3 squared equal 12. Can I use the square root property? Yes, I can use the square root property. So I'm going to go ahead and rewrite this over. When using the square root property, I take the square root of both sides. What else do I need? Plus or minus. The next step is to remember that the square root and the square undo each other. So what's left? 2x plus 3 equal plus or minus the square root of 12. So that's where I'm at. All right, you got to remember some things that we've done in the last 5 hours. 3 hours from the first day, 2 hours from today. That's the 5 hours I'm referring to. What else can I do before I go any further by getting x by itself? Simplify the square root of 12. Remember we did that earlier? So everything you've learned is always a prerequisite for where we're going. What perfect square goes into 12? 4. 6 is not a perfect square. 4 times 3, right? And what's the square root of 4? So that's 2 square root of 3? All right, so this becomes 2x plus 3 equals 2, plus or minus 2 square root of 3. So that's what you have to do next. You have to simplify the square root of 12 if you can. Simplify the radicals if you can. Simplify the radicals if you can. And now the rest is just like we did in number 4. So when you go back to number 4, remember number 4, I had the square root of negative 16. I simplified it, right? I ended up with what? Plus or minus 4i. I had the square root of 12. I simplified it. What did I end up with? Plus or minus 2 square root of 3. Once I simplified the square root of negative 16, what was the next step we did? Get the constant from on the other side and then divide by the coefficient. So what do you think the next step is here? By doing what? Subtract 3. Just like this. Combine like terms, I get 2x equal, and how do you write this side? Negative 3 plus or minus 2 square root of 3. One more step when you're done. One more step and you're done. Divide by 2 and you're done. Okay, now, so that's your answer on my math lab. On my math lab, you're going to say this. It's going to say separate the solutions using commas. Because how many solutions are there? 2. So when you write this, don't think there's just one. There's how many? 2, because the numerator is 2 binomials. So you have negative 3 plus 2 square root of 3 over 2, comma, and then the other one is negative 3 minus 2 square root of 3 over 2. And if you want to write them as separate fractions, you can. My math lab, they'll accept this. They'll say, all right, you can write as negative 3 halves plus what? 2 square root of 3 over 2, comma, and then the other will be negative 3 halves minus 2 square root of 3 over 2, right? But you could also do this. Could someone else have noticed this? Well, these twos divide out, right? So could someone else have said, well, I'm going to write this as negative 3 halves plus the square root of 3. Is that correct? No, it's correct. Why not? Why is that not correct? You can't reduce the twos? Wait, what now?
Oh, never mind. Oh, never mind.
No, you can reduce the 2. 2 to 2 is 1, 2 to 2 is 1.
I didn't see we were separating.
Okay.
So.
Comma, and then here that's minus 3 halves minus what? The 2's divide out. What are you left with? Square root of 3. So those are all different ways of writing the answer. But mistake people make is this. I need to see this. I'm going to write this over right here. This is a mistake. I'm sorry. This is a mistake people make. They'll say this. Oh, I see some 2's here. I'm going to do this. And then say the answer is this. That's not true. You can't reduce these 2's like I'm doing here. Because you see how there are 2 things being divided by 2? So if you reduce this with that one, well, what about this one? You can't just throw it away. All right, so that's incorrect. You know it's incorrect because look, you're supposed to have a what in the denominator? A 2. I don't have it. All right, so don't reduce like that. When you reduce this this denominator has to go in every term, not just this one, but what else? That one. We're gonna see one like this when we get to it, but that's a mistake. That's a mistake people make. So don't make that mistake. Okay? All right, let's look at this. All right, so let's look at number 6. Number 6. You have 3 times x minus 4 squared minus 15 equals 0. Don't make it difficult. 3 times x minus 4 squared minus 15 equals 0. All right, so I want to see if I can use the square root property. In order to use the square root property, what's being squared has to be by itself. So what's being squared? What's in parentheses? What's in parentheses? X minus 4. So that means I got to get the other stuff on the other side. So what do I need to do first? Add 15 to both sides. So I get this, right? Now let me say the other mistake people make. Did any of you want to distribute that 3? Yes. Cannot. Cannot distribute the 3. The only time you can distribute the 3, remember when we did all those distributions? Can I distribute here? Yes. Yes. That's 4x minus 20. The reason you can distribute here is because this exponent is a 1. That's why. Is this exponent a 1? No, so you can't distribute. If you go back to all the problems you've done, if you find all your notebooks from many, many years ago, and I know you kept them somewhere in your closets, if you go through them, when you did distributive property, it was always, that parentheses is always raised to the first power. You can't distribute here. Because that's not a 1, that's a what? 2. But you still got to get rid of the 3, so what are you going to do? Divide both sides by 3. 3 to 3 is 1, so on the left side, what do you end up with? equal what?
5.
5. So that's where I'm at. All right. Now I know what to do. What's the next step? Square root. Take the square root of both sides. Plus or minus. So the square and the square root undo each other. So what do I get? X minus 4 equals plus or minus square root of 5. And now the rest is actually there's just one more step. What's the next step? Add 4 because the coefficient of x is 1. So what's the answer? 4 plus or minus square root of 5, right? On my math lab, how many solutions are there? 2. What are they? 4 plus square root of 5, comma, 4 minus square root of 5. Those are your solutions. Okay, now, look at this one. Two x minus 3 squared equals 144. Just like before, you know what to do. Do I have something squared equal a number?
Yes.
Yeah. So what's the next step? Square root both sides. Take the square root of both sides. Plus or minus. So the square and the square root undo each other. So what's left? Equals plus or minus 12. Okay, good. Plus or minus 12. Okay, now let's just continue on like we did with the other problems. What was the next step? Add 3. So I get 2x equals 3 plus or minus 12, right? Then divide by what? 2. And so x equals 3 plus or minus 12 divided by 2. Okay, now listen. Listen to this. This is not where you're going to stop, though. And here's why. When I go back to previous problems, like let's say this one, where I had negative 3 plus or minus 2 square root of 3, are those like terms? No. They're not like terms. This has a square root of 3 and this does not. They're not like terms, so you left it alone. You left it like this. That's all you could do. The other one, let's see, that was number 4. Let me find number 4. Number 4, what's this one? When I wrote it like this, are these like terms? No, they're not like terms. This doesn't have an I in it. I think that was probably it. So, all right, so let's talk about this one now. Here's the question. Can I say 3 plus 12 is 15?
Yes, you can.
Can I say 3 minus 12 is a negative 9?
Yes.
Yes, so you need to go further. So you have to say this. You have to break it down. And you have to say 3 plus 12 over 2, and then 3 what? Minus 12 over 2. And that's 15 halves. That's what you would write. You would write 15 halves as your solution. And this is negative 9 halves. So you have to go further because 3 and 12 are integers, so I can combine those, okay? So whenever you don't have a square root, if this was like 12 square root of 5, then you leave it alone because I can't combine them. If that was 12i, you leave it alone. I can't combine them. But I know that I can combine 12 and 3. So go further. Okay? All right. Now, let me just kind of remind you about rational and irrational again. Okay, here's the question. How many solutions do I have here? 2. How many solutions do I have here? How many? 2. Okay, so what are my solutions for number 7? X equal 2 things. What are they? 15 halves, comma, negative 9 halves. Those are your solutions. Okay. What kind of numbers are these right here? Rational or irrational? Rational. Remember, a rational number is where you have an integer divided by an integer. That's a rational number. So is 15 and 2 integers? Yes. Is negative 9 and 2 integers? Yes. Do you remember what your integers are? 0, 1, 2, 3, 4, 5, and so on. So your whole numbers and your negative counterparts. Negative 1, negative 2, negative 3, negative 4, and so on. Those are your integers. So are all these numerators and denominators one of these things listed? Yes. That's what makes it a rational number. I can write it as a fraction where the numerator and denominator are integers. Now go to number 6. Is number 6, is this solution an integer? No, because the square root of 5 is not an integer. So this is what kind of solutions? Rational or irrational? Irrational. So this is irrational solutions. These are what kind of solutions? Rational solutions. Okay? Go to number 5. Go to number 5. Where's number 5? Oh, here it is. Number 5. Rational, irrational? Irrational. Square root. The 2 square root of 3 is not an integer. So it's an irrational number. Number 4. Be careful. Oh, nope. Okay, so remember, real numbers, you've got to remember this. Real numbers, there are 2 types of real numbers that we've dealt with so far. Rational and what? Irrational. This is not a real number. This is a what? But complex number, right? So what kind of solutions are these? Complex solutions. Complex. We talked about complex last time, remember? A plus BI? All right. So remember, real numbers are imaginary, irrational or rational. This has an I in it, and that imaginary part's not 0, so that makes it complex. It's a complex solution, imaginary solution. So you can say complex solutions, or you can say imaginary solutions. You want to say imaginary, you can, because you see that I, right? Imaginary solutions. But the fact that it has that 4i with it doesn't make it rational or irrational. It makes it, you can say, either complex solutions or imaginary solutions. Okay? All right, let's look at this. All right, listen carefully to this, and don't start crying. All right. So remember last semester, and I know at least half of you took Math 99. Those of you that did take Math 99, and even if you didn't, the prerequisite you had to have made a B in Math 99 to be in this course, or have a placement score, right, on ACCU, whatever they call it. All right. So what I'm about to ask you is this. If I have x plus 3 times x minus 1 equals 0, okay? If I have x plus 3 times x minus 1 equals 0. Now, if I were to FOIL this out, the left side, what kind of equation is this? Huh? It'll be quadratic. That's a quadratic equation. So let's go ahead and FOIL it out. I just want to show you something. What's x times x? What's the outer? Negative x. What's the inner?
3x,
And what's the last?
-3.
Negative 3. So combined like terms, I get x squared plus 2x minus 3, right? So that's just right here. So this is x squared plus 2x minus 3. So what kind of equation do I have? Quadratic. Now remember last semester, when I go from here to here, what is it that I've done?
Well,
Factored. I factored. I factored this trinomial, and I got this, right? You factored. So there's a whole chapter on factoring. In fact, last semester, if you recall, almost everything you've done in that course was involved factoring. Now, when you factor, each of those things I'm pointing to are called factors. They're called factors, okay? So remember that. They're called factors. So for example, if you look at 8, and I tell you that 8 is 2 times 4, which it is, right? So that means that 2 is a factor of 8, and 4 is a factor of 8. I could have also said 8 times 1. 8 is a factor of 8. 1 is a factor of 8. So when I factor this, when I write this as a product, each of these things are called factors. Notice that these two factors are being multiplied together and their product is what? 0. All right, let's think about that. If you have two things whose product is 0, what must be true about one of these things? One of them must be 0, right? That's the only way you can get 0. One of them must be 0. So if I'm saying that this product is 0, then one of these factors better be what?
0.
I don't know which one, so we are going to set each one equal to 0. So I'm going to say x plus 3 equals 0, and what's the other one? X minus 1 equals 0. And then notice, I went from a quadratic equation to two linear equations. How do you get x over here? So what's one of your solutions? Negative 3. How to get x over here? So what's one of your solutions? 1. How many solutions does this quadratic equation have? 2. What are they? Negative 3 and 1. And you can check it. Let's check. So when you check, you always go back to the original. And so notice that this side has to equal what number? 0. So let's check 1. 1 squared plus 2 times 1 minus 3. I want to see that's equal to what? 0. What's 1 squared? What's 2 times 1? So what's 1 plus 2 minus 3? 0. Let's check negative 3. Now remember, with the negatives, you got to put parentheses, right? So negative 3 is being what? Squared. Plus 2 times negative 3 minus 3. I want to see if that's equal to 0. What's negative 3 times itself? 9. What's 2 times a negative 3? Okay, so I have 9 minus 6, which is 3, and 3 minus 3 is what? 0. All right. What I've done here, see when I went from here to here? That's called the zero factor property. So you need to know that word, zero factor property. Zero factor property. And basically zero factor property says this. All it says is this, just like we talked about. If I have two factors and I'm telling you that product is 0, then one of them has to be what? 0. That's all it says. So if I have A times B equals 0, then either A is 0 or what? B is 0. That's a zero factor property. Okay? All right. Now, let's look at this. So this is going to be Number one, I want you to solve this quadratic equation. Number one. Don't make it difficult. I'm gonna make this one a little bit simpler to where you could guess as to what it is. Let's see. All right, let's suppose I had this quadratic equation. X squared plus x minus 12 equals 0. X squared plus x minus 12 equals 0. All right, I'm going to ask you this. The way it looks, can I use a square root property? No. Because what do you see? An x term. If that x wasn't there, then could I use the square root property?
Yes.
Yeah, I would have to bring 12 to the other side and then take the square root of both sides. Okay? But the fact there's an x term, I can't use the square root property as it is. So I want to factor. I want to factor. All right. So remember when you did factoring, you have a trinomial. That's where you broke it down to two binomials. Remember that?
Mm-hmm.
Okay. So how do you factor x squared plus x minus 12? That's where you use the reverse FOIL. Use a reverse FOIL. You thought about the FOIL method. That's what you did. You did the factoring last semester. You did the idea of that FOIL, the reverse FOIL. So let's think of the F first. What times what is x squared? X times x. So you knew that had to be an x and that had to be an x. Now let's go to the last. Our last term is a negative 12, right? In order for these two last things in here to be negative 12, one has to be negative, the other one has to be positive. And there are multiple possibilities you can use. Negative 6 times 2, negative 4 times 3, and so on, right? Not all of them work. You got to try the one that does work. So what do you want to try? 4 and 3?
4 and 3.
Positive 4, negative 3? All right. Now you got to check, though. You have to check. If it doesn't work, you try something else. That's what you did last semester. We're not doing last semester all over again, because that chapter took almost a month. So I'm assuming, and if you can't, you need to go to Canvas where I have all that stuff from last semester in there, if you need to review factoring. But so let's check and see if this is true. All you got to do is just check the outer inner, because negative 4 times negative 3, I'm sorry, positive 4 times negative 3 is what? Negative 12. X times x is what? So all you got to do is check the outer and the inner. What's the outer? No, what's the outer? Negative 3x. What's the inner? What do I get when I add them up? X. And is that my middle term? Yes. So what you have is correct. That's what you did last semester. You did a trial. Remember it's called trial and error? That's what you did. Hopefully it's not, but that would have been the more challenging part, is factoring. Once you get the factoring, everything else is straightforward. Those are called what that I'm pointing to? Factors. What do you notice about these two factors? Their product is 0. So what property are you going to use? Zero factor property. So basically, zero factor property says if I have two or more factors and their product is 0, one of them better be what? 0. All you do is set each one equal to 0. So what are you going to say?
X plus 4 equals 0.
And what's the other one?
X minus 3 equals 0.
Notice you're always going to go, for us, you're always going to go from a quadratic to two what? Linear. So what's x over here? And what's x over here? So those are your solutions. Negative 4 and 3. All right, let's do 3. Let's do 3. You have 4x squared plus x minus 3 equals 0. 4x squared plus x minus 3 equals 0. What kind of equation is this? Can I, the way it's written, can I use the square root property?
No.
No. So let's factor. Two binomials, right? Two binomials. So let's see if you remember some stuff from last semester. What do you want to try for 4x squared? 2x and 2x. That's what I would try. Now, it doesn't always work, so if it doesn't, you're going to try 4x and what? 1x, or just x. That's what you did. But let's try 2x and 2x, see what happens. What about -3? Now it's -3, right? The last sign's negative. That means that the inside signs are going to be different, positive and negative. And 3 is prime, so there's only one possibility for 3, and that's 3 and what? 1. So let's put the 3 here and the 1 there. Make one of them positive, one negative, and then you check. So I'm gonna do this wrong. Let's say that I make one positive and 3 negative. Okay. So when you do that, don't assume that what you have is correct. You got to, in your mind, check and make sure it is correct. Because 2x and 2x is what?
4x.
A -3 times 1 is what?
3.
-3. And so some students, what they'll do is they'll see that and say, okay, then I'm done. I just got to set each one equal to 0. It's not correct. Because you got to do the out and the inner. What's the outer? 2x. What's the inner? -6. What okay when I add them up? -4x. That's not what I wanted. What did you want? X. So something's wrong with my terms. And even if I switch the 1 and the 3, it still wouldn't work. So what does that tell you? Huh?
Signs are wrong.
Say it again?
Your signs are wrong.
Nope. Not that. That has nothing to do with the signs being wrong.
You can't use 2x.
I cannot use 2x and 2x. I have to use what?
4x.
4x and x. That's what I have to use. Okay? And let's put the 3 here and the 1 there, and let's do it again. That was what you did last semester in factoring. That's what you did. You went through that process. Now let's make the 3 negative and the 1 positive, and then let's check. What's 4x times x? 4x squared. What's the -3 times 1? -3. But you got to check that middle term. That's what you did. What is the outer? 4x. What's the inner? -3x. What do you get when you add them up? X. And is that what you wanted? Yes. So now you factored it correctly. You factored it correctly. What's the next step? Zero factor property. Once you factor, you said each factor equals 0. That's a zero factor property. So 4x minus 3 equals 0. X plus 1 equals 0. This one, let's do the x plus 1. That one's easy. What's x over here? -1. All right, over here, I'm going to say 4x equals 3. So it's x. 3/4. So there's your solutions. -1 and 3/4. Okay. But there is a set of problems that they're going to ask you to solve by factoring. And then there's a set of problems where they're going to ask you to solve by quadratic formula. We're going to do that as well next class period. And then there's a set of problems where they ask you to solve using completing the square. Now, you have not dealt with completing the square probably unless you remember something from maybe advanced math. But we are going to do completing the square. I'll give you the steps for that next class period. Yes?
Keep plugging 3/4 into the original equation. Because, I tried to do that.
Okay, so he wants you to check 3/4, right? Now, what did you think you can do? You can, when checking fractions, what I would do is I would convert 3/4 to a decimal, because I can then just put everything in decimal form and use a calculator, right? So what's 3/4 as a decimal? 0.75. So if you want to check 3/4, right there, that's 0.75. So you have 4 times 0.75 squared plus 0.75 minus 3. Minus 3, and we'll see if that's equal to 0. Now, hopefully you do this by using a calculator, right? Okay, so in your calculator, you would then say,
You looking for a calculator?
yeah, well, now I'm gonna get mine. I had mine out, but thank you though. Because I know how to use mine. I don't know how to use yours. All right, so you're gonna say you're gonna say on your calculator, you're gonna say 4 in parentheses 0.75 squared, and then plus 0.75, and then minus 3, and then press equal, and what do you get? 0. That's the way I would check it. I wouldn't check it the long way where you use 3/4 and then you do one thing at a time, because on a test you don't have that time. Okay? But that's what you do in your calculator. Use your calculator when checking. Now, what he wanted me to do, I would imagine, is actually leave 3/4 as 3/4. Okay? And let's do the long way. What's 3/4 times 3/4? 9/16. So that's 4 times 9/16, right? Plus 3/4 minus 3. Well, let's reduce. 4 to 4 is 1. 4 to 16 is what? 4. So that's 9/4, correct? So I have 9/4 plus 3/4 minus 3 over 1. When adding fractions, you got to find the LCD. What's the LCD here? 4. 4. 4, 4, and 1.
Oh, yeah, that's right.
4. So these are already 4, so that means that both of the numerators are going to be what? 9. This is going to be 3. Now remember how you wrote equivalent fractions. Said 1 times what is 4?
4.
What I do to the denominator, I do to the numerator, so that's 12. All the numbers are the same, so you just add the numerators. What's 9 plus 3?
12.
And what's 12 minus 12? 0. That's what you wanted. All right. So that's checking the long way, but you have access to calculator, use it. Okay? All right. So we're gonna next class period we're gonna continue with quadratic. So far all we've done was use square root property and then factoring, right? All right. Some of you are a little rusty on factoring because as I was looking at you, smoke was coming out of your head. Eyes were rolling back. But for some of you, you remember these things. You remember how to factor. But you have to know how to factor in this course. It's not the difficult factoring. It's not the difficult factoring. You don't have to know anything about. Remember last semester you did difference of 2 cubes, sum of 2 cubes. You don't have to do that in here for what we're doing. You did it last semester, so it's the easy kind of factor. You just got to remember how to do it. All right, so you can't leave just yet. You have 15 minutes. All right, so.